Hello, everyone. I'm Nakao from the University of Tokyo, and also I'm co-chair of XGMF. So now I know the reason why the keynote speakers came here. I understand, because I can't see the slides. All right, so my talk title is Advancing 5G and 6G Technologies through Global Collaboration for a Connected Future. And today, I came here to introduce our new organization, XGMF. I'm a professor at University of Tokyo, but at the same time, I wear several hats at the government. And also now, it's separate from the government, although the government fully backs up our organization, XGMF. But we started a new activity, so I'd like to introduce it to your Korean friends and also international friends. So XGMF launched, and this is a consolidation of 5GMF, which has been promoting 5G deployment and monetization in the past. And Beyond 5G Promotion Consortium, B5GPC, so this is for pushing the 6G R&D in Japan. And the reason why this consolidation is that, it's not efficient to separate these activities because every country has a problem of monetizing 5G, because I heard lots of keynote speakers speaking the same thing. So then we decided to combine the effort, promoting 5G technologies, and at the same time we push R&D of 6G. So that's why we started this new organization called XG. And look at the logo. So the X is doubled, so it's not 20G, and it's not 10G either. So we are pushing 5G and 6G, but in the background, we think that G may not stand for 10 years anymore. We can keep thinking about looking into the future. So that's why we call it XGMF. So I'm skipping several slides because we have a press time. So the XGMF's goals in international relationship is that we have to share 5G and 6G global information, because we have to know what other countries, what other organizations are promoting which technologies. Because we learned from 5G that the investment for this costly infrastructure, we need to be very, very wisely moved, and we have to efficiently invest money on this new infrastructure. So then we have to, people understand that, so this technology, mobile technology, is globally standardized. This means that, we have to understand that the driving factor is a global value that we pursue for future society. So that's why we like to identify global priorities. And we are we started talking to several other organizations about, what other countries are setting the priorities to. So today I heard a lot about AI, a lot about NTN, a lot about upper mid-band frequency, and we started conversion. I actually observed that we are starting converging on particular technologies, and we have to wisely invest on those prioritized technologies. And the second goal is, of course, strengthening the international coordination, because building consensus and pre-standardization, because we already started doing the 6G standardization activities in preparation for full-scale launch of the 6G in 2030s, and we have to work hard on that. And the third goal is that promoting international and industry-academia collaboration. I like to stress that academia should play an important role, because we are talking a lot about advanced wireless, NTN, and I can switch my hat to a University of Tokyo professor later, and what we are up to, and I can introduce our activity aligned with the government policies. So we have to work closely with industries and academias and internationally, so that we can develop 6G technologies all together. Okay? So this is an organization of XGMF. People find it very interesting or strange, because we have lots of projects on top of a project management office. So this is basically divide and conquer approach. So anyone can propose a project. Anyone who thinks that this technology is important, they can start a project, and it gets approved by PMO, the project management office. And it's sort of democratizing the 5G and deployment and a 6G R&D by defining the projects. And of course, we have a small resources, human resources. And these projects will talk to each other and converge into larger, the combined project. And for example, Nakamura-san here, he's presenting tomorrow, is organizing, the several 6G related projects, and I'm doing advisor to those projects. So this is pretty unique. I didn't, find any other organization which takes this form. But there was a long debate on defining this structure. We will see that maybe the next generation XGMF may take a different form, but so far we defined 26 projects already, and one of them is 6G promotion. And also projects have two goals: the promotion of mobile utilization and the technological development, and also the creation of new industry and businesses. So let me take a look at, I said 26, but now 24 plus new projects are listed. And I can't go into the detail, but the slides are shared. So you can take a look at what kind of projects are there. And of course, that includes NTN and advanced wireless also. But as I said, this is divide and conquer approach. Not a single person can take responsibility of developing a wide variety of technologies. Okay, so let me switch my topic a little bit to our ministry. A very nice talk the previous speaker from Network Policy Director of the Ministry of Korea spoke about the strategies. And I'm introducing only 3 slides from Japanese ministry's policies. So the progress of Beyond 5G initiative. So looking back, we have about 774 million US dollars investment already. So this money goes to NICT, and this funding got granted to companies and universities. I actually got several funding for projects as a university professor, but there are 72 projects funded. This is different project than XGMF projects, but this is like a funded project, 72. So at some point, if I'm allowed, I'd like to share the list of these projects so that you can find some partners to collaborate with. Okay? And also G7 vision for future networks in the beyond 5G, 6G era. So they define the directions of the international vision on the beyond 5G and 6G already. So this is a rather busy figure, but it's not my fault. This is shared by a ministry. So this is the big picture of the ministry is a strategy. So digital infrastructure that will support AI society in the 2030s. So I was surprised to see this slide for the first time, because this is the first time that I saw a slide from the Ministry of Internal Affairs and Communication that put AI up front. So this is basically saying we have to develop a network for AI. So people are saying AI for networks or network for AI, but the ministry thinks that we have to develop, look at the highlighted part, the providing a green, safe, secure, and reliable AI to the entire society through beyond 5G. So we have to use 6G, beyond 5G technologies, but the main objective is to deliver green, safe, secure, and reliable AI to the entire society. So for that, they set up 3 strategies. And the first one is all photonic network, APN. So you know that the NTT is promoting ION Global Forum. So all photonic network, low power, low jitter, low latency communication. Although it's a wired network, so they think that it's part of beyond 5G. And the second one is a non-terrestrial network, NTN field. So yesterday, I think my colleague presented NTN project within the XGMF. So we are developing hubs, the high altitude platform stations. There are two big movements in Japan. So the one is led by SoftBank. The other is led by NTT Docomo and NTT. Combined, it's called the Space Compass company. And they plan to launch the service in 2026. Right? So that is also supported by the government funding. Okay? And although we have already seen that great success of Elon Musk, so we have Starlink. We mainly use that for backhaul of the telecommunication companies. But the satellite communications, we already saw the value of that. So, introduction of globally provided services like Starlink, OneWeb, we support R&D to utilize those technologies. Of course, we have to develop things like that, but they are moving very fast. So first, we think about the utilization of such global service. And last, not the least, radio access network RAN, the advanced RAN field. So we talk about a sub-6 deployment and millimeter waves and a standalone, So this is repeated many times in the previous speakers. And also, we have to secure frequencies for upgrade of RAN. So these are the three strategic areas of the ministry in Japan. So I said that the AI is promoted mainly by ministry. So I think many of you have already saw this in Mobile World Congress in Barcelona this year. So we saw lots of AI alliance. One of the biggest one was announced was AI RAN Alliance. And major global vendors are demonstrating the power of AI. So I think this is unavoidable movement, I think. So, I borrowed these slides from my friends in Nokia. So AI-enabled telecommunication, the part of this is provided by Nokia people. But application of AI to telecommunications are many. So fault prediction and fault detection and advanced signal processing, like highly parallelized processing, and also inter-cell coordination, DMIMO. AI, native AI interface, you already know that two speakers already talked about this. Juho Lee gave a wonderful talk about non-uniform constellation. So we believe in these things are the future. And also JCAS, not many people pointed out this, but I think this is also sensing by AI and efficiently deliver the radio wave to users. This is very important movement. And also the low power telcos are looking for low power equipment. And there are lots of algorithms to deep sleep and micro sleep and to save the power because the power amplifier is the main source of the power. So we have to reduce that wisely. So this is from the discussion with SoftBank. So I think there is another problem of the sustainability of the telco business. And users are looking for AI inferences, right? People use ChatGPT every day. But on the other hand, it's very hard to maintain the infrastructure, putting investment into 5G and 6G development, right? So, but people are leveraging edge AI. So, and one way to make a telco business sustainable is to make edge cloud, which can serve two purposes. One is for short latency AI inference, low latency AI inference, and the other is AI RAN. For example, imagine that the same edge cloud, which has a lot of GPUs, can serve low latency inferences, and about at the same time, the AI RAN, advanced RAN. So this way, as an ROI, it's going to be healthy, and SoftBank thinks that this is the direction. So I got very interested in this AI RAN alliance, and for the first, I'm now switching my hat to a University of Tokyo professor, and we insisted that we should be part of it because academia can play a very important role here to contribute to this AI-based RAN. So we have AI for RAN, and also AI on RAN, and AI and RAN. So AI and RAN is exactly this idea. So AI and RAN on the same infrastructure. But we are mainly interested in AI for RAN. So we would like to use AI for RAN processing, right? So I'm very interested in Jeff Lee's slides, and I like to, we should be doing a lot of that in AI RAN, AI for RAN working group. Another thing is ORAN. So ORAN has a group of ORAN RIC, which is also AI integration into the open interface. And I don't have to teach you how RIC works, but we have traffic steering, power management, resilience, and dynamic spectrum sharing use cases. And the last one is very important, I think, because upper mid-band, 7 to 8 gigahertz band, so it's shared by many other purposes. And in order to use that, instead of millimeter wave, instead of sub-6 to gain high speed and wide coverage, so we have to wisely use that so that we can do a dynamic spectrum sharing, predict the usage of the frequency and switch between the frequency bands. So this is what we need to do. So, and we are looking at especially power management, resilience, dynamic spectrum sharing, traffic steering. So there are lots of telco interested in that, but as academia, we are targeting at 3 main topics like this. So I gave a keynote at ORAN. If you are interested, there's a recorded video, maybe you can take a look at. And so this is, if among the cloud, so if there are university professors, so this is what we do for a project. So we already demonstrated AI-enabled robust and resilient 5G systems. We use the cutting-edge AI technologies called feature learning to predict the traffic, and also deep reinforcement learning to optimize the 5G core network functions. So another thing is that enhancing network slicing, predicting the application traffic by and adjust the QoS for that. So there we have used AI for traffic classification and better network slicing. Okay, my last topic is the Mobile Direct project, Rakuten, AST Mobile, and UTokyo. So already Starlink, Elon Musk took the heat of the Mobile Direct, but we have been working on this topic for long, and there's a big difference between Starlink's Mobile Direct that was announced a few months ago, but this is not the same architecture as a Starlink Mobile Direct. So we are using bent pipe. So the signal coming from the UE is going to the satellite, but there's no G node B, E node B on the satellite. But instead, we have the giant antenna. So So there are two differences between our approach and Starlink's approach. One is that we are not taking the regenerative satellite E-Node B, but instead we are doing bent pipe so that we can modify the E-Node B on the ground station so that we can upgrade the infrastructure. And in the end, it's very hard to upgrade the E-Node B in a satellite, but we can upgrade the base station on the ground pretty easily. So this is sustainable evolution that you can ensure. Okay, but the end goal is the same. You take that phone, but a modified phone can connect to the satellite and then to the E-Node B on the ground. Okay, so then you can take the phone anywhere, but it gets hooked. So the bandwidth that we are looking at is a little bit less than the Starlink satellite, but we can we get the high gain because of the very large antenna loaded in satellite. So we are working in ASD mobile, and in August, our experiment in the Midland was successful, and we demonstrated. But then again, the Starlink took out the heat of this mobile direct. Okay, we will see that Rakuten may move very fast to commercialize it. If you are interested, we already published the paper and are presenting that in December at Globecom. So this is the basic idea that I developed, and then SoftBank, so Rakuten can take this idea and implement that in a real, to be on the ground. So we will see. But, for this example, I would like to stress that NTN is very, very important for coverage. We can't stress too much of that. It's very important. So, and I'm very happy that the Japanese government put that NTN as one of the goals of the 3 strategic goals, because it's very important. We have to work on that. Okay, so in summary, I saved 2.5 minutes for the next speaker. So in summary, XGMF is committed to shaping the future of global connectivity by advancing 5G and 6G technologies at the same time. Okay, and we'd like to identify the global priorities. So please join us. Let's discuss and define the future. Thank you very much for your attention.
Thank you, Professor Nakao, again.